Hello everybody, thanks for tuning in. I wanted to take a few minutes and just kind of make the connection between the unit circle, graphing, sine and cosine, and then introducing some new characteristics of the graph. And so let's just jump right in. Up in the upper right hand corner I've got the unit circle, and it's kind of a mini version of it. And I only entered in the values on the unit circle that have whole numbers, just because that's easy to work with, and they're kind of at these nice critical values of 0, 90, and 180, and 270. I also color coded it just to remind you that the first coordinate, which is in purple, represents cosine values, and the second coordinate, your y coordinate, represents in green your sine values. And so we did this in class a little bit. We used some technology, but if we go around the unit circle, I'll start with cosine, and we'll do that up here at the top. What this point right here, this 1 means is at 0 degrees, cosine has a value of 1. And at 90 degrees, that's up here, cosine has a value of 0. And we can start going a little bit quicker. At 180, we're at negative 1. Whoop. Drops down here. And at 270, we're back at 0. And remember, 360 is back here at 1. And so on my graph, it looks kind of like a V, but I'm expecting you from class and from your explorations to know that if we filled in other pieces, you'd end up getting this nice smooth curve. One thing I want you to get out this video and to memorize about cosine, it's going to help us with later graphs, is that cosine starts at a high point. You hear me say that a bunch. Cosine starts at a high point. So we could keep that going if we go around the circle again, but I'm going to move on to sine really quick. So I'm going to switch to green to make everything nice and pretty. So sine's in green, and sine represents these. And same logic here, but you're going to have different points. At 0 degrees, sorry guys. At 0 degrees, sine is 0. Up here at 90 degrees, sine is 1. 180, sine is 0. 270, sine is negative 1. And then at 360, again, back at 0. And then it starts all over again. You can go back up here, back down here, as long as you'd want to go. So you end up kind of having the nice same curve, but now this one, again, up at the top, I said cosine starts at a high point. You can think of sine, starting in the middle, or at the origin. So one of their characteristics that makes them different is they kind of start in different places. Sine, I'm circling it right now, sine still has a high point, but it doesn't really start there. So that's going to help us define these features. All right, so that's our background. What I really want to introduce today, and kind of the reason for this, is something called the amplitude and the period. Amplitude is what we'll start with. And if you have an equation like sine, sometimes there's a number in front of it. I'm going to put a for amplitude. You have the same thing with cosine. And you guys have seen things like y equals mx plus b. You've seen that a ton. And remember that each of these variables represents something. And usually you can use them and maybe have a shortcut or graph it quickly. And so I want to show you really quick what the amplitude means. It's going to save you some time moving forward. So let's say up here, I ask you to graph 3 sine theta. So just real quick so you can see it in comparison. remember that the original sine, so I'll do the original one in black. The original sine starts at the origin, and then it goes up to 1, comes back down, and kind of looks like this and goes on for a while. When you have an amplitude change, in this case the amplitude change is this 3, what it does is it essentially stretches it vertically. So watch how I label the axis. It's going to take, oh my gosh, come on. It's going to take these points and stretch them down so they max out at 3 and negative 3. If you really want a visual on it, again, I have the luxury of color, but this distance right here is 3 units. This distance right here is 3 units. And that's how the amplitude and this coefficient kind of affects the graph. It stretches it vertically. Let me do one with cosine. Maybe you can see it a little bit better. So down here on the bottom, let's change it. What do we want to do with? I already did purple. Orangish. Let's say we have a, just for kicks, 10 cosine theta. So the original one, remember, the original one tops out at 1. That's like your standard. Bottoms out at negative 1. So what that means, and it's all about how you label the graph, which is why it's so important. The original cosine graph just stops at 1. Say this is a 1 and a negative 1. And remember from my last picture that cosine starts high. It starts at 1. So this purple one's the original one. Cosine would come down, you come back up and do this. But when you have an amplitude change, and in this case using this orangish color, it says the amplitude is 10. It means that it's going to start at 10. It's still going to start high. Remember, cosine starts at a high point. Cosine starts at a high point. It's still going to start high, and it's still going to bottom out low. But now that distance between the top and the bottom is 10 units. So this distance is 10. This distance is 10. This distance is 10. So that's kind of what I'm saying about the amplitude. If you want another quick little example with it, in class we did spend a little bit of time, making a t-chart. If we have theta and sine of theta, we have these points. 0, 90 was 1. 180 was back at 0. These are those 5 points that we graphed, or negative 1. And then when you get to 360, it's back at 0. And we also included like 30 degrees and 60 degrees and some of these things. But if you think about making a table where you just change the number in front, maybe this becomes a 4 sine theta, and you still use these values. Just think about what this does. It's just taking the old values, which were 0, 1, 0, negative 1, 0, and it's timesing them by 4. So it'd be 4 times this, 4 times this, 4 times this, 4 times this, 4 times this. And you end up getting these new values, 0, negative 4, 0. In the long run, I want you to be able to skip this, but if you plot these points, the first one's 0, 0. The second one says 90, and then 4. That means I go up 4, and that's where it's going to top out at. At 180, boom, it's back at 0. At 270, looking at this point, it's down at -4. And if I'm going too fast, you can slow down the speed, you could watch it again, but you can see this curve developing. And it's the same sine curve. It's always going to have the same shape. It's just the dimensions, in this case the amplitude, have changed. So it's kind of cool. You can think of it as a table, but hopefully, after you do a few of these, you can just say, okay, I know where it's going to start, and you can kind of jump right in a little bit, just like you would with a linear equation back in the day. Okay, I'm going to stop the video there. I'm going to make another one about period, but that's a little background on amplitude. Amplitude, amplitude, amplitude. And just as a closing thought, because I have a minute or two before YouTube kicks me off, amplitude is always the number in front of the argument. It can be for sine or cosine, but the number in front, that coefficient. I'll use A because it represents dun, da, 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 the amplitude. Thanks for watching.